Welcome back, students. Let's resume. Not here, here, initial value problems. We talked about the first two problems getting harder. Harder and harder and harder. Okay, let's go with this one. Solving the equation, that's the easy part. dy dx is equal to x times y to the 1/2 power, and thus all the y's on the left hand side, all the x's to the right hand side, y to the negative 1/2 power, dy is equals to x times dx. Did I do this right? And then take the antiderivatives of both. Separation of variables. Actually, this is the easy part. Okay, let's calculate the antiderivatives. Add 1 to the power and then divide. So I need reciprocal here. And 1/2 x squared. And then I need integral constant c. 2 divided by 1, so let's just write 2. And is it possible to solve for y? Looks like you can do that. So y to the 1/2 power is 1/4 x squared plus c over 2. And c over 2, that's just constant to be determined, so take another constant. And then square both sides. Y equals to 1/4 x squared plus k, total quantity squared. And there goes my solution, general solution. Now, how do you determine k is going to be the problem? And k will not turn out to be arbitrary, as a matter of fact. You see, we have square root of y here, so that's always positive. So if k is too small, then this whole thing may become negative and we may have a bit of a trouble. So keep that in your mind. Maybe I'm giving away a bit too much. Anyway, setting up the separation of variable and getting a general solution is easy part. Hard part begins now. Let's get those solutions based upon the initial conditions along with the intervals of definitions. Okay, all right. By the way, okay, all right. And then let's go to blue. Y is equal to 1/4 x squared plus k, total quantity squared. Y of 0 is this whole thing. So that's 0 squared is equal to 0. So what do we have? That's 0. K squared is 0. We are getting k is equal to 0. Did I do this right? So 1/4 x squared plus 0, total quantity squared, because k is equal to 0. And this can be simplified further. 1/4 squared, so that's 1/16, and this is going to become 4th power. And that's going to be the solution of the blue problem. Looking good? Okay, how about the red problem? Oh, by the way, what about the interval of definition? Any singularity here? Looks like it's okay all the way. Okay, let's go to the red problem here. Okay, all right. Y equals to 1/4 x squared plus k, total quantity squared, and then y of 0, which is this one, is equal to 1. Okay, all right. So k squared is equal to 1, isn't it? Is that right? That drops out. Okay, all right. So k is either 1 or k is -1. All right. So what do you have? Y is equal to, when k is 1, 1/4 x squared plus 1 squared, or y equals to 1/4 x squared minus 1 total quantity squared. Looks like that's what I'm getting. That's what I'm getting, looks like. And how about the interval of definition here? How about the interval of definition? We're looking at a polynomial function. Either way, no singularity, no nothing. So it looks like everything is fine. So here comes the solution. How do you like these? Well, separation of variable and taking the antiderivative and then solving for y, that's elementary. Putting into the initial value condition and then finding out the solution, that too is elementary. And then again here, putting into initial condition and finding out k values so that we get the solutions, that too is elementary. Something bugs me because things are too elementary, too easy. I don't see any singularity anywhere, no denominator, no square root or anything like this. So interval of definitions are simple, negative infinity to positive infinity. Is it supposed to be really this simple? All right, let's go back to this notebook and let's see if we have a surprise. The general solution, okay, all right, same thing. I'm using t here, no problem there. The initial conditions, we got that. Wait a minute. The same thing we got before, yeah. But wait a minute, I'm claiming there's another solution. Oh, let's go back to this. Well, looks like as if I missed this one. How in the world? What's going on here? Let's go back to this general solution and plug those in. Am I getting any different k value or anything else? Nothing, absolutely nothing. But still, there's another solution there, and let's see if this is really a solution. Y is constantly 0, so y is constantly 0, so this is constantly 0, so that's constantly 0. And how about the derivative? Of course, the derivative is constantly 0 for constant functions. So yes, we have 0 equal to 0. So it is a solution, yes, but I completely missed it. Well, this kind of solution is called singular solution. Sometimes trivial solution. And those do not follow regular rules. And that's why it is called singular. You just have to anticipate it and consider those. And especially you have to pay attention to zeros, the derivative becoming 0. Here's a visualization. We have those direction vector field, and then we have those general solutions, and then this is a solution curve that's going through the initial condition 0, 0. And then look at this flow. Around the x-axis, they're kind of dying down. And then at the x-axis, we have the singular solution. So there is a surprise. Okay, there was a surprise. How about the second problem here? Is that complete, or is there any other surprise here? Okay, all right, the general solution is the same thing we did before. Oh, I'm giving away a bit too much. And from the initial condition, we got the following, and we got this and that. All right. We got two solutions. Okay, two solutions here, and the visualization here. And we follow the arrows, following the arrows, and we have this green solution, and that's behaving wacky. What do you mean by wacky here? That's this solution here, this green curve, and then look at this dotted part. Dotted part. Dotted part is not following the arrows. It is going transversally with all the other solutions. So something is wrong here. This dotted part is not a solution. And this initial condition follows the initial condition here, 0, 1, falls in a region that we have dotted curve, which is not really a solution. What's going on here? Does it mean this one is not a solution? Indeed, it's an extraneous solution. The first solution is okay, but the second solution is not okay. And you can actually check that. Put this one and then put this one into original problem here and take the derivative. Okay, take the derivative, took the derivative, and then factor x out. Well, I'm using t, so t out. And we have 1/4 t squared minus 1. Is this really square root of I? And as a matter of fact, the answer is no. Why not? Because this thing is negative. You see, t is 0, so this part is 0, or close to 0 when t is close to 0. And then minus 1, this thing is negative. It's not square root of I. This part here is not equal to square root of I. This is negative, and that's positive. That's why it fails. As a matter of fact, you see, yeah, square root of y is 1 minus 1/4 t squared, you see. This one's positive, not 1/4 t squared minus 1. So the green solution here is extraneous. And where's the visualization there? As you can see, this portion of the graph is behaving wacky. And if I go beyond 2 and negative 2, it's okay. This portion is following this arrows, and again, this one too. The middle part is bad. What's going on here? What's going on there? As a matter of fact, over here, not all C satisfies this. Let's see, from here, divide by 2, the square root of y is 1/4 t squared plus divided by, okay, I'm using same c's here and there, so I'm causing a bit of confusion here, and for that reason I changed c to k in my solution there. Let's just look at this part. Over here, this is square root of I, so that's positive, and then 1/4 t squared plus c, that whole thing has to be positive in order for this thing to make sense. So c has to be greater than or equal to negative 1/4 t squared. Now, in this case, if we have negative 1 here, Okay, if you have negative 1 here, then negative 1 is greater than negative 1/4 t squared. In other words, 1/4 t squared is less than positive 1. So t squared is, something is not right. I flipped the order. Yeah, okay, all right, that should be greater. Multiplying by negative number, we have to flip the order, the direction. So t squared is greater than 4. So what do we have? T is greater than 2, or t has to be less than negative 2. Negative 2 comma, no, negative infinity comma negative 2 union positive 2 infinity. In these two intervals, this green solution I had before, where is it? The solution is valid. Here it is valid. In these two intervals, the solution is valid. But our initial condition, x equals to 0, t equals to 0, did not come from any of these. So this one is extraneous. Let's go back to the visualization there. Look at the green solution there. Beyond positive 2 and beyond negative 2, we have solid curve here, and those follow the direction field. They are following the arrows, so they are okay. But in the middle, they're not behaving okay. You see this? So that one is extraneous, so you have to cast it away. So we have this questionable solution there. This one was mostly okay. If you write like this, then if this had been an exam problem, maybe 90% of the credit, yeah, you're gonna get that because, well, that part is completely gone. Okay, all right, and then you missed a singular solution. Not too bad. But here, this one is big, missing this extraneous solution there. So this part, you're going to miss about half the credits. So, for example, if this had been a big problem, 5 points here, and then this one, you're going to earn about 4.4 out of 5. And then this one, about 3 out of 5. Kind of like that. So this solution here, questionable solution here, is not really a great solution. Here, black part, all correct, no problem there. Blue part, I missed a singular solution. Just a little bit, but still not perfect. Here, big mistake. This one I completely missed. This one is extraneous. So, what's the moral of the story? I don't know. I cannot really say anything except that the separation of variable problems can be really hard when it comes to the analysis of solutions. Finding a solution, that's easy. Analysis of solution, that can get really, really bad. Okay, that's where I'm gonna stop, and I'll say section 1 is done, and we're gonna talk about an example of separable equation, the logistic model or epidemic model. We're going to talk about section 2 in a separate video.